Okay, so what is a mole? So a mole is the amount of substance that contains Avogadro's number of molecules. And what is Avogadro's number here? It is 6 times 10 to the 23, so a very large number. And so where does this number come from? Essentially and simply, this number is the number of molecules that's in 12 grams of carbon 12, okay? And so, why do we want to know the mole? We want to know the mole because when we're looking at chemical reactions, we have molecules reacting with each other. And so, we need to have a way to change grams, the everyday real life mass measurement that we use, into number of molecules. And we can do that simply by expressing number of molecules as moles, which is just a different unit to expressing as single molecules. We can express it in a system where we use this and call it 1 mole. So if the whole purpose is switching between grams and moles, really, and so forth, how do we do that? And so if we want to go from moles to grams, we need something called the relative molecular mass, or the MR. And when we're going from moles to grams, what we need to do is multiply by that. And when we're going from grams back to moles, what we need to do is divide by that. And so what is the relative molecular mass? The relative molecular mass is the sum of all the relative atomic masses of everything in that molecule. So, for example, if we have this molecule over here, CH3COOH, how do we work out the relative molecular mass of this? By adding the relative atomic masses. Where do we find that? On the periodic table. So if we go to our periodic table and we see each of the squares, if we look at carbon, for example, we'll see the atomic number above it, the number of protons, which for carbon is 6, and we'll see below, we'll see the relative atomic mass, which in the case of carbon is 12, okay? And if we go to each of these, we can find out carbon's 12, hydrogen's 1, and oxygen is 16 based on our periodic table. And also to mention, the units of that is grams per mole, because this measurement is telling us how many grams of something we'd have if we had 1 mole of it. Like, remember I said, if we have 1 mole of carbon, we have 12 grams of that, because carbon 12 is the normal isotope that exists usually of carbon. And so anyway, back to relative molecular mass, or MR. How would we calculate it for this? Well, if we count the carbons here, we have 2. So we have 2 carbons, which would be 2 times 12. We have 4 hydrogens, which would be 4 times 1. And we would have 2 oxygens, would be 2 times 16. And remember, what are these numbers here? These numbers are the relative atomic masses, or also called atomic weight, and this comes from the periodic table. And so what is this all together? We would have 2 times 12 is 24, plus 4 times 1 is 4, 24 plus 4 is 28, and then 2 times 16 is 32, so you have 28 and 62 gives us 60, okay? And so 60, what's the units again? Grams per mole, okay? So now we found out our relative molecular mass for a compound, so let's do an example. If we had, let's say, for example, just make it very easy, we have 120 grams of our ethanoic acid here, this compound here, okay? If we have 120 grams of that, how many moles do we have? And so we look at our equation over here. To go from grams to moles, we want to divide by the relative molecular mass, okay? And so if we take this 120 grams and we're dividing by 60 grams per mole, we'd find out there we have 2 moles of it, okay? Relatively straightforward, relatively simple. Okay, so what about if they give you moles of something and tell you to work out how many grams you have, okay? So if we look back to our equation there, if we wanted to go from moles of something to grams, we need to multiply by our relative molecular mass there. And so let's look at an example. We have 5 moles of this molecule here, CaCl2, okay? So we have moles and we want to work out grams, we need to multiply by the relative molecular mass. So let's work out the relative molecular mass. So looking at our periodic table, we have Ca, calcium here, is 40 grams per mole. And Cl2 is 35.5 grams per mole. Okay, and we have 2 of those. So we add that all together, we get 111 grams per mole. Okay, and so now we have 5 moles of CaCl2, which we found out altogether has a relative molecular mass of 111 grams per mole. And so we times 5 by 111 gives us 555 grams of CaCl2. Okay, so what about if they give you moles of something and tell you to work out how many grams you have? Okay, so if we look back to our equation there, if we wanted to go from moles of something to grams, we need to multiply by our relative molecular mass there. And so let's look at an example. We have 5 moles of this molecule here, CaCl2. Okay, so we have moles and we want to work out grams. We need to multiply by the relative molecular mass. So let's work out the relative molecular mass. So looking at our periodic table, we have Ca, calcium here, is 40 grams per mole. And Cl2 is 35.5 grams per mole. Okay, and we have 2 of those. So we add that all together, we get 111 grams per mole. Okay, and so now we have 5 moles of CaCl2, which we found out altogether has a relative molecular mass of 111 grams per mole. And so we times 5 by 111 gives us 555 grams of CaCl2. Okay, so we found that we could start from grams and go to volume of a gas. And so how do we do that? Is when we start with grams, we know now we can divide by the relative molecular mass, and that will give us moles. And now we know there's something called molar volume, and molar volume tells us how much volume a certain number of moles will take up of a gas, of course. And so that's the problem we just did, that type of problem. But what if they ask us to go the other way? What if we started with a volume of some gas and we had to work out how many grams or how many moles even? So if we go backwards, we start with the volume, then how would we get to moles? We'd have to divide by the molar volume. That would give us moles then. And then if we wanted to go to grams, how do we go moles to grams? We would have to multiply by their relative molecular mass. So let's just look at one example. If we have 50 liters of, let's say, carbon dioxide gas, CO2, at standard temperature and pressure, which we know means there's 22.4 liters per mole, how many grams do we have? And so let's do these steps here. We have 50 liters, that's our volume, and we need to divide by the molar volume, which we've told under these conditions are at 22.4. And so we've got 50 liters over our 22.4 would give us, liters per mole there, would give us 2.23 moles. And now we've got moles. How would we go to grams? We would need to times by the relative molecular mass. And so our relative molecular mass for CO2 here is our 12 here plus our 2 16s is 44 grams per mole. And so how many grams do we have? We have 98.12 grams of carbon dioxide gas in 50 liters.